Hello everyone, I am Miss Amruta Zadav ma'am, and as we have started the session of thermodynamics, we are here with the part 5. So we have covered 4 parts of the same chapter, and I hope you all got all the 4 parts of it. Now we will move towards the part 5, in which we are going to study some facts about the PV diagram and the work done. Does the work done depends on path or not, that we are going to see in this lesson. Alright, so let's move towards our session, and before moving towards today's lecture, we have to revise what we have done in the previous one. So the points which we have covered in the previous lecture was, first one, thermodynamic equilibrium. There are 3 types of equilibrium. First is mechanical equilibrium, in which force is 0 and even pressure is same. Then we have seen chemical equilibrium, in which there was no reaction within the system and even within system and its surroundings. So that was chemical equilibrium. And the third, which is most important, and we are continuously saying this, is thermal equilibrium. What is thermal equilibrium? The temperature remains same throughout. So these are the 3 types of thermodynamic equilibrium. And the second point, which was thermal state variables and equation of state. I guess I have covered this point in live session also. That was, what was the state variables? When we study any kind of thermal system, thermodynamic system, we usually take example of a cylinder which is having gas enclosed in it and which is having piston on it. Whenever we describe any kind of system, we usually denote it by pressure, volume, temperature, mass, density, internal energy and work done. So these all are variables. So these variables are actually of 2 types. One of them, it doesn't depend on size, and some of them it depends on size. So the 2 types of variables are intensive and extensive. When we call intensive variable, when they do not depend on size of the system. What are they? What will be the example of intensive variables? Pressure, temperature. These variables do not depend on exact size of the system. So these are intensive variables. And some variables are there which depend on the size, and which are the internal energy, total mass of the system. These 2 variables do depend on size of the system. So these are known as extensive variable. So that 2 types we have seen, and while considering all these state variables, we have studied, we can put it into a single equation that we can consider. And the single equation which is worldwidely used was ideal gas equation, which is nothing but PV is equal to nRT. By using that equation, we have also seen a PV diagram, and we have studied all the concepts which are related to PV diagram. How does it looks, a PV diagram? PV diagram is nothing but on y-axis we plot pressure and on x-axis we plot volume. So while considering this kind, PV is equal to RT suppose. So in this, only 2 do depend on each other and third remains same. It may be P and V. If we consider P and V, so in this case T remains same. That means it is constant. So we have plotted many kinds of graph of it, and we have seen that when the work done becomes positive by using the PV diagram, and even when the work done becomes negative, and when it is doesn't change. So that what we have studied, by considering either volume remains constant or pressure remains constant, or sometimes temperature remains same. So by using that, what we have actually studied by using PV diagram, work done. Okay, so as we have studied some concepts regarding work done, now in this lecture also we are going to see some more things which are related to work done. So let's not waste time and let's move towards our today's lecture's point. And what are they? Let's see. The first point that we are going to consider or study is thermodynamic process. Then the second point which we are going to study is work done during a thermodynamic process and heat added during a thermodynamic process. So these 3 points we will cover in this lesson, in this lecture. So let's move towards the first point. What is that? Thermodynamic process. So what exactly comes in your mind when we read a word thermodynamic process? There should be some process that happens in the system, so that's why we are calling it as thermodynamic process. So while we say that some process happens, what is the effect of that process on the system? Basic thing, the initial states of the system can change to the final states. Alright, suppose we are considering any subsystem is having pressure P and it changes to P3. So the initial state will be P and the final state will be P3. So this is nothing but the thermodynamic process in which we are saying that a system changes from initial state to the final state. Now what happens during this change exactly? Heat may be transferred or may not be. Work done can be happen or cannot be. What happens exactly in this? So the answer is, during such change there may be transfer of it into the system from the surrounding. Now when there is a transfer of it from environment to the system, then it is nothing but negative heat or positive heat. Yes, it is positive because system is gaining heat, right? System is gaining energy. So in that case it is positive. When a system is given out the energy, then it will be a negative one. So any kind can happen in this. Work done can be negative, it can be negative. Energy can be positive, can be negative. Any kind can happen during the thermodynamic process. Okay, so this is all about the thermodynamic process. Now the question is, why to do such kind of process? Why to change the states from one to another? So as to maintain the equilibrium. What I asked that why to happens or why to change the state from initial to final or from one point to another. Why it should be changed? Because thermodynamic equilibrium should be there in any kind of system. Okay, so such processes in which changes in state variables of a system occur very slowly are called as quasi-static systems. Okay, processes in which changes in the state variables of a system occur very slowly are known as quasi-static systems. So when thermodynamic system changes, again I am saying the same thing, from initial to final, it passes through a series of intermediate state. It passes through series of states. This series can be plotted by using PV diagram again. So we are using that PV curve so as it will tell you how the system can be changed. So by using PV diagram we are going to see how the state can be changed and how the work done is being maintained or how the system will be in thermal equilibrium. Okay, so I hope you got this thing. So let's see the next point, which is work done during thermodynamic process. Now Here I haven't written any theoretical part. I just wanted you to observe all the diagrams and I will explain all the diagrams over here. So theoretical part is not there on the slides. So let's have a look at the first diagram. What you can observe, I will take a minute so that you will take a look at the first diagram. On y-axis, pressure is there. On x-axis, volume is there. And what are these things which are there inside it? Here in this case, A is initial point, B is final point. That you have to remember throughout this point. A is initial point and B is final point. Now, they have given many paths to cover a distance from A to B. Path 1 is directly from A to B. You can see over here. What is path 2? Path 2 is from A to C and then C to B. What is path 3? It is from A to D and then D to B. Okay, I hope you got this diagram right now. What they have given us numerous paths by which we can change the state from A to B. Now let us explain what exactly point A is. As we said that A point is initial state. So if we write it is in coordinate forms, what it will be? A only. For A in coordinate form, it will be, see, you can see over here, A is having pressure. What is the pressure of A? It is Pi. And what is the volume of A? It is Vi. So coordinates will be Vi and Pi. So this is point A. And similarly we can write for B. B is having volume Vf and pressure Pf. So this is in coordinate form, point A and point B. Now we are going to see the path which are following to convert from A to B. Let us consider the first one. The first path which is directly from A to B. What you can observe by looking at the first curve. In this case, A is having pressure Pi. While moving towards B, pressure decreases or increases? Obviously, pressure decreases. And volume, what happens to the volume? For the first curve I am talking. Let's see separately. So here is the diagram which shows you the curve which is first one. So in this case, pressure decreases and volume increases. You can see over here as the curve is going downwards. And then as volume increases, so what will be work done? Work done will be positive. And how we can give you the value of work done? As we have seen in PV diagrams before this, that will be the shaded area under the curve. So all the shaded area which is there under the curve AB is nothing but work done by the system. Okay, so this is the simplest curve which we have studied right now. Now we are moving towards the second path. How the second path is going from A to C and then from C to B. Now we'll look at it separately. Here you can see, while moving from A to C, while changing the state from A to point C, what remains same? As here you can see, pressure is same as it is a straight line. So pressure remains same but volume increases. Pressure same and volume increases. Then again from C to B, while moving from C to B, pressure decreases and volume remains same. So sometimes pressure remains same and sometimes volume remains same. So it is in alternative ways. While moving from A to C, pressure is same and volume changes, increases. While moving from C to B, volumes remain same and pressure decreases. So in this case, again, the area which is under this path will give you idea about work done. Okay, so this is nothing but the shaded area. Here you can see this, the shaded area which is under the ACB is work done. Okay, so next one, the third way. What is the third way? From A to D, from A to D and then D to B. While moving from A to D, we'll discuss in the separate one. Yes, here you are. While moving from A to D, volume remains same and pressure decreases. Here you can see volume is same while moving from A to D, but pressure decreases. Now that has to move towards B. Now the pressure will remain same as it is P over here. Pressure will remain same and V increases. So the area under this will give you the value for work done. Now observe all these diagrams. What you can observe or what you can conclude by observing all these diagrams. Consider the three diagrams. Skip the first one and look at the first here. Have a look at this diagram and this diagram. What you can conclude by using these three diagrams? Work done is different in all the cases. Is it? Yes, in first case work done, which is area under the curve, is different than second diagram, and that is from the third diagram. So what you can conclude from all of this? You can conclude that work done by a system depends not only on the initial and final state but also on the path which is followed by the system. So this is the main thing that we have to learn in this. So work done not only depend on the initial and final state, it does depend on the path which is followed by it. Okay, so here you can conclude from these three diagrams, you can see that work done is different in all the three cases. So it depends on the path. Okay, so this is all about the work done. Now let's move towards the next point, which is heat added during a thermodynamic process. Now, very simple point. I will explain it in very short period. As the heading itself says, heat added during the thermodynamic process. So, thermodynamic states of a system can be changed by adding heat to it. As we know that we can add heat to it. So, there are two methods by which we can change it. Okay, so by directly adding heat by burner or by putting that system into a insulated material. So let's have a look what we can do in this. So the first diagram which you can see over here is the first case, in which we are going to consider cylinder which is having gas and a piston which is movable, frictionless and massless, that we all know. Now suppose the volume is Vi initially and it goes to final volume Vf at constant temperature. We are saying that it should be at constant temperature. So as to maintain the temperature, I am giving heat to the system very slowly, so as to maintain the temperature. As I am giving heat very slowly, so the volume will increase slowly, so it expand really slowly. So it is controlled manner. Why is it so? So as to maintain the temperature. It reaches the final volume after some time. It reaches the final volume Vf isothermally. The system absorbs final amount of it during the process, that you can see over here. How the volume changes? By adding external heat to it, but it should be in controlled manner. so that to maintain the equilibrium. Now we are going to see the second condition. What you can observe by looking at the diagram, there are two cylinders over here. First is before picture and second one is after picture. So I will give you one example. You must have heard the example, or you all have tried this in your childhood while playing with the balloon. If you pin that balloon, what happens? It suddenly shrinks. It gives out the air out to the surrounding. So what happens to the balloon exactly? As the air inside it was tightly bounded, when you pin up that balloon, in a fraction of seconds all the air which is there inside the balloon goes out freely. It try to go out because it gets the way to go out. So this is the free expansion. While in rainy season, even in rainy season, the dams are full, the windows of the dams are open. While they are opening, all the flow of water will come out very fastly as they are given a way to go out. So that is nothing but the free expansion. I hope you got the idea about free expansion. काय सांगितलं मी एक्झाम्पल, बलूनचं एक्झाम्पल सांगितलं आहे. बलूनला जर का तुम्ही पिन मारले तर पटकन त्याच्यामधली सगळी एअर बाहेर येते, कारण त्याला वे मिळतो एक छोटासा, की ज्या वेवमधून ते एअर ब्लो आउट होऊ शकते. सिमिलरली सेकंड एक्झाम्पल मी सांगितलं रेनी सीझनमध्ये खूप पाऊस झाल्यानंतर डॅम एरिया, ज्यावेळेला डॅम फुल होतो त्यावेळेला कुठल्याही डॅम्सचे डोर्स ओपन करतात. ज्यावेळेला डोर ओपन केलं जातं त्यावेळेला खूप फास्ट प्रेशरमध्ये पाणी बाहेर येतं. विदिन अ मिनिट खूप फास्ट प्रेशरमध्ये पाणी बाहेर येतं. का? कारण ते आधी बंद होतं कम्प्लिटली आणि त्याला एक वे मिळाला वेन इट इज ओपन. सो वेन इट ओपन्स इट कम्स आउट व्हेरी फास्टली, इमिजिएटली. सो दॅट इज नथिंग बट फ्री एक्सपान्शन. सो इथं सेम आपण अप्लाय करणार आहोत. We are going to consider same cylinder which is having gas in it and it is enclosed in insulated material so that heat will not transfer to the surrounding. हा एकच मेन पर्पज आहे in this. Heat should not transfer to the surrounding or not from the environment to the system. It should be insulated. Okay. Now what happens in this case? It is divided. The gas cylinder is now surrounded by insulated material and it has been divided into two compartments, okay, which is X and Y. X is having volume VI and Y is having volume VI dash. So the total will be VI plus VI dash will be the final. Okay. So the compartment X of the cylinder is filled up with same amount of gas at same temperature. Okay, you can see in the diagram over here. X is having gas in it with the same temperature, and the compartment Y, you can see over here, it is empty. So it is empty. It contains no gas, no other particles, not at all in it. Now after some time, what will happen, as the compartment is been divided into two and one is having gas molecule and another compartment is fully empty. So after some time the partition is now what we are going to do is partition is now broken. When the partition will broken, what happens to the gas molecule if it is broken? So all the gas molecule will try to go towards the empty space and they will expand themselves. So the gas occupies all the empty space before the partition is broken. If a single breakage is over there, it will try to move. It will make a way to move, to fill up all the empty part over there. So this is nothing but free expansion. Now in this case, no heat is added to the surrounding or nothing is coming inside from the surrounding, कारण आपण त्या इन्सुलेशनमध्ये ठेवलेलं आहे. सो द हीट विल नॉट गो आउट अँड हीट विल नॉट कम इन. ठीक आहे. सो ह्या एक्सपान्शनला वॉट वी आर सेइंग ॲज वी टेकन सम एक्झाम्पल, इट इज नथिंग बट फ्री एक्सपान्शन. ओके. सो इथे बलूनचं एक्झाम्पल दिलेलं आहे. अनदर देर आर मेनी एक्झाम्पल which you can consider for the free expansion. There are many. Okay, so this is all about this, how we can add heat to the thermodynamic system that we have studied. Okay, now this is all for today's lecture. So here are the points which we have learned today. What points we have learned? We have learned that thermodynamic process, then work done during thermodynamic process, it depends on path which is followed by the system, the main thing which we have learned. And the third point which we have learned was heat added during a thermodynamic process. In two format we have added, directly or by insulation. Free expansion we have seen in this point. So this is all for today. Thank you so much for listening all the video. Thank you so much. If you have any kinds of query, please do ask me. I will try to solve your query. Thank you so much.